Hey guys, we are on day 2 of Unit 4, and we are going to be reflecting our functions today. And so in number 1, it says that the parabola f of x equals x squared minus 6x plus 5 is shown on the grid below. So we have to remember that this is f of x. Okay, and then it says consider the function g of x is equal to negative f of x. Determine a formula for g of x and graph it on the grid below. So what's going to happen is that we're literally going to put a negative in front of all of f of x. Okay? So we're going to go ahead and say that negative f of x would be equal to negative, and because we're putting a negative in front of something that has 3 terms, we're going to have to make sure that we put the negative in front of the whole thing, meaning that the whole thing goes in parentheses so that the negative is in front of everything. Okay, and what that's going to happen is, first off, that this negative f of x, they want us to call it g of x, so we're going to turn that into g of x. And then we're going to take that negative and we're going to distribute it. So that's going to turn into a negative x squared. This is going to turn into a positive 6x. And this is going to turn into a negative 5. Okay, and so we determined a formula, and now we're going to go ahead and graph it. Okay. And we're going to graph it by taking that equation and putting it into our y equals, and we're going to generate a table of values. Okay, so go to y equals. If you got something in there, clear it out. And then type in negative x squared plus 6x minus 5. You can go to graph if you want to see what the picture is going to look like. Or you can go second graph, and we're going to get a table of values. Okay, we're going to look for that symmetry like we looked for when we were doing the absolute value v's on day 1. Okay. And with parabolas, usually a good amount of points is the number 7. In fact, the one that is graphed on your paper has 7. It has 3 on one side, the turning point, and then 3 on the other side. So we're going to try to do the same thing. So if you figure out that turning point, that middle, okay, is actually 3, 4. So I'm going to put it in the middle of my table, and then I'm going to go 3 points below it. So I'm going to go 4, 3, 5, 0, and 6, negative 5. And then I'm going to go 3 above it. So it's going to go 2, 3, 1, 0, and 0, negative 5. And then I'm going to go ahead and graph it. Okay, so 0, negative 5. Careful with 0, negative 5. 0 means no left and right. 5 down. 1, 0, 2, 3, 3, 4, 4, 3, 5, 0, and 6, negative 5. 1, 2, 3, 4, 5. Okay. I'm going to go from the turning point in a nice smooth curve this way. Okay. And from the turning point in a nice smooth curve that way. Okay. All right. And that is going to be g of x. Okay. So part B says, how was the graph of f transformed to produce the graph of g? And if you notice from geometry that this is resembling a reflection over the x-axis. Okay, so we're going to go ahead and say that a reflection over the x-axis. Okay, and so what that negative actually did was it changed all my y coordinates. Okay, because when you reflect in the x, you change the y. So you change the y coordinates. All right, that's just a little hint that might help us later. Okay, and so going back up, when you put a negative in front of f of x, remember f of x, okay, is really y, and so you're negating y, and so that kind of makes sense, okay, if you think about it. Okay, let's go ahead and take a look at C. And C says, now consider the function h of x. And h of x is equal to f of negative x. So they squeeze the negative in here now. Determine a formula for h of x and graph it on the grid above. So we're going to go ahead and steal our f of x. Okay. So we're going to go ahead and say f of negative x is equal to, okay, and remember, basically what this means is f of x is going to become f of negative x. So all the x's turn to negative x's in the f of x equation. So we have x squared, but that x is coming out and negative x is going in its place, and we're squaring it. Okay. Then we have minus 6x. We can keep the minus 6, but the x is coming out and negative x is going in. Okay. And then we have plus 5, which has no x's in it, so it stays. Okay. And what they wanted me to call this is h of x. So this is now going to become h of x equal to a negative x squared really means negative x times negative x. And two negatives multiplied together give me a positive x squared. Okay. And then a negative and a negative will make a positive 6x and then plus 5. Okay. And there is my equation for h of x. Now they want me to graph it on the grid above. So I'm going to go to my calculator. Okay. I'm going to go to y equals. I'm going to clear it out. I'm going to type in x squared plus 6x plus 5. You can go to graph if you want to see a picture of it, or you can go second graph and go right to the table of values. Okay. We're going to go ahead and look for the turning point. If you see the symmetry in the y's, okay, if you scroll, and the turning point is at -3, -4. Okay. 3 points below and 3 points above. Okay, so below would be a -4, -3, -5 is 0, and a -6, 5. Okay, 3 above would be at -2, -3, -1, 0, and 0, 5. Okay, and we're going to go ahead and graph them. So 0, 5, be careful. 0 means no left and right. 5 up. 1, 2, 3, 4, 5. Okay, -1, 0. -2, -3. -3, -4. -4, -3. -5, 0. -6, 5. Okay, nice smooth curve that hits all your points with arrows. And this one is called h of x. Okay, and so part D asks, how was the graph of f transformed to produce the graph of h? So the original one that was printed on our graph, how was it transformed? And hopefully you guys know a little bit from geometry and what we're talking about today. And this is a reflection over the y-axis. Okay. Remember that when you reflect over the y-axis, you actually change the x-coordinates. Okay. So if we go back and we look at that, it kind of makes a little bit of sense now. When we do f of negative x, right there, you're changing that x coordinate by putting the negative on the x. Okay, so hopefully that kind of reminds you. If you see the negative with the x, you're changing the x, which means it's a reflection in the y-axis. Okay, whereas over here, if you see that negative in front of that f of x, you're changing the y, and when you change the y, it's a reflection in the x-axis. Okay, all right, hopefully that helps. It's kind of outlined for you on the bottom of our notes there. Okay, you can see. Okay, and then I'll see you guys on the back side.